Hello learner, welcome to Manifested e-learning platform. My name is F.A. Mlingwiri and I practice within the financial services industry in Kenya. Ladies and gentlemen, today we are discussing about equity valuation models. To begin this lesson, we are going to discuss about the dividend discount model, single stage, two-stage and multi-stage models. So this is Excel, and what I've done is that the usual cells have actually been done away with. Say for example, I've actually come here and I decided to, you can see the colors over there. So I decided if I put no fill right over here, you'll be able to see the typical Excel worksheet like that. But for simplicity's sake or even for visual presentation, I felt it would be good for us to come right there and then we put it a white background like that. So the discounted dividend model is a model that was, or what we can say the constant growth model was developed by Gordon. And under the single model, it assumes that the firm expects to pay a dividend in 1 year. So we can say, so we can write that the firm expects to pay dividends in year one, in 1 year, in 1 year. The second assumption is that dividends grow indefinitely at a constant rate. Dividends grow indefinitely at a constant rate, indefinitely. Yes, so that is it there. And finally, the third assumption is that the growth rate is less than the required return. The growth rate is less than the required return. So those are the assumptions, and for simplicity's sake, what I can be able to do is that I can select all of them, the three assumptions, as I move down like that, and then I press Control bold, and then Control bold, it will unbold that. So if you press Control B, I'll bold that. Control B again, it will unbold that. So these are the assumptions of the DDM. And under the DDM, specifically the single stage DDM, it assumes that the firm expects to pay a dividend in 1 year. So this is the historical dividends, the D0, then 1 plus G. So if I grow it by a factor of G, which is assumed to be constant, then I should be able to get the expected dividends, the future dividends, and so on and so forth. So the firm expects to pay dividends in 1 year. Dividends grow, the next assumption is that dividends grow indefinitely at a constant rate. So the growth rate is constant, and this graph depicts that constant growth rate. So you can see the 3.5% dividend is constant, or the growth rate in dividends is constant from time 0 through to time period 9, and indefinitely moving towards the right there. So this graph tries to explain this second assumption. The third assumption is that the growth rate should be less than the required return. So the R should be less than the G, like that over here. So if I can put brackets onto this part right here, that to represent constancy, this model and this one over here, the best way to try and apply this on Excel is by looking at an example. So the example on your screen reads as follows. Down Under Financial recently paid a dividend of 1.8 Australian dollars. An analyst has examined the financial statements and historical dividend policy of Down Under and expects that the firm's dividend rate will grow at a constant rate of 3.5 indefinitely. analyst also determines down unders beta is 1.5, the risk-free rate is 4%, and the expected return on the market portfolio is 8%. Calculate the current value of down unders shares. So what we'll do is that we need to try and identify, have we been given historical dividends as depicted over here, denote historical or current dividends. So the key terms there that you should be able to watch out for is historical dividends, current dividends, past dividends. That one should signify the denote, and you should be able to grow the denote so that you can be able to have the expected dividends and forecasted dividends into that. The D1 represents the forecasted and future dividends. The G is the firm's growth rate, and R is the cost of equity or required return. Now in this case, we have been given the following inputs. So the key word there is denote. So we have, I just pick that one over there, Control C. I pick that, and I can be able to paste it down over here, Control V. So the solution down over here, solution there. And because I do not want it to be bolded, Control B, like that. And so if I have the denote, because we've been told the recently paid a dividend of 1.8 Australian dollars. So that's the value there. So if I can be able to just move down or control up. So you move up like this, my apologies. We can just move down like this just to bold. So we unbold that, so Control B, that, and of course because I can see that it seems to be bolding, I just press Control B like that, and also this part over here, Control B like that, so that now when I write subsequent inputs towards the formula, then they'll not be bolded. So denote is 1.8. What else have we been given? We've also been given the dividend, the firm's dividend rate will grow at a constant rate of 3.5%. So the G has been given to us over there as 3.5%. Fine, that's fine. And then what else have we been given? We've been given an analyst also determines that down unders beta. So the way to do it is that if you want to come to beta, you can just come to insert over here like that, and then we can go to symbols. So when we go to symbols, we can just click over here, symbol, like that. And then from symbols, we can try and look for beta right over here. I can see it is right over here. So we click that and insert it over there like that. And then we close this screen like that. And beta has been given us how much on this other side. So we are saying that the beta, pardon me for that, and the beta has been given as 1.5. And then we have the risk-free rate. The risk-free rate has been given to us over here as 4%. 4% RF. So capital RF has been given to us there as 4%. And then, of course, this RF should be the risk-free, should signify the risk-free rate. But if perhaps you'd want you to indicate, that should be subscript over there. So you press Control 1 right there, Control 1. And you can see over here, there's subscript over here, and click that, and then you say, okay. So the F becomes subscript. That's the risk-free rate like that. So it's like that. So because we're just using some of the shortcuts that you've learned in the previous lessons, there is the expected return on the market portfolio. So it's ERM, like that. So M should also be subscript. So Control 1 again, and then we highlight, so we cancel, we escape. Then you say, we just highlight the M should be subscript, expected return on the market. So we press Control 1, and then we come to subscript right down over here. Press OK. The expected return on the market portfolio is given as 8%, like that. So trying to put in a formula, we know R is given as expected return of the portfolio. R is given as, we can put that is equals to, R is equals to RF, so let me write it and then I'll be able to edit it again, plus, open the brackets, ERM minus RF, then we have beta over here. So we just come back to insert symbol over here. So the keyword there is insert symbol, like that, and then you select the beta right over there. So you just insert that over there, then you close that. So that is the formula over here. This is the CAPM formula, CAPM. So CAPM. That. So this should be, of course, control bold B, like that, you put it like that. And of course, editing is just something that, of course, you'd have to do, you'd have to learn to do, like that. So we press control 1, subscript, let's press subscript there, like that. And then also RM, M should also be subscript. So control 1, then you come to subscript, like that. Then you press OK, like that, and our formula is done. So this is required return. Remember, we've already provided the cost of equity or required return. So R, because we've been given the inputs towards calculating required return, we have the RF right over there. So we have also the ERM, and the RF has been given, the beta has been given. So you just apply it over here. So we have all of the inputs, and I can, of course, explain it down. So so our required return is given as, we put the inputs there, RF, there. Then we put in the values over here. So then I can just delete over here. So required return is given as, we're just following the formula. RF, so we put the formula plus, so we come RF, like that, plus, we open the brackets, ERM minus RF, like that. Then we close the brackets over here, and then we multiply this. So we multiply that by the beta. So where is the beta? By that value over there. So how much do we get? Enter 10%. So our required return is 10%, which is going to be our R right over here, R. G over here is going to be, it's already been provided as 3.5%. But remember, we've been given D naught because the keyword there, we've been told, is recently paid. So it has to be historical. We have to grow it over there. So we are saying our price, market price, or intrinsic value, like that, is equals to, there's no need for, I can just copy this over here, Control C, come down over here, paste it down over here, Control V, pardon me. So I just copy, come over here, and just paste it down over here, Control V, like that. So it's equals to that. That's what you're saying is our market price, guys. So it's slot in the values over here. So market price, using the single stage model, is given as, is equals to, plus the D naught, so we go up, times, we're just following this formula, 1 plus G, open the brackets, 1 plus, what is our growth rate here? Our growth rate is there, 1 plus G, divided by divided by, so because we're dividing all of that, the entire numerator by this denominator, R. Where's our R? Remember, we calculated it over here, and you can be able to convert it into percentage over here. First of all, R minus G. And our G is how much? 3.5%. So we close the brackets over there and we say equals 28.66. So this is what we can say as the market price over here. And this is the single stage DDM. In our next lesson, ladies and gentlemen, we are going to do the two-stage DDM. And the two-stage DDM will also apply a similar kind of approach, where we'll be able to explain to you what the single-stage formula DDM, two-stage, not the single-stage, the two-stage DDM is all about. And then I'll walk you through a question that will be able to do it physically on Excel. Thank you for being with Manifested Publishers. God bless you.